Hello and welcome everyone to Versa DataKit community meeting. The community meeting is there to bring this open source project to the wider public. Anyone who is interested can ask any questions. We have discussions on our progress around the meeting, around the project, and so on. For those who don't know what is Versatile DataKit, I'm gonna just quickly share my screen. So we are an open source project, and we're developing a framework to develop, deploy, and operate data workflows with Python and SQL. And you can find our repository here, just Versatile DataKit on GitHub. And if you scroll down, you can read a little bit about the project, all the components or like features that we have, data ingestion, transformation, deployment, operations, plugins. And if you wish to contribute to the project, you can also find how to connect with us. So yeah, that's basically a brief overview of what is the project. And I also want to just briefly introduce the team. If I managed to... Okay, no, I can't stop sharing for some reason. The people from the team, maybe you can just turn on your cameras and just give a little wave. We have here Stanley, Paul, Duigu, also Dilian, a couple more people. Also Dako is involved with this project. And some more people you can see. If you wish, you can also just unmute yourself, say hello, and I'm gonna.
Everybody on three. 3, 2, 1. Oh, okay. 1, 2, 3. Hello.
Hello. Nice. Okay, so on today's agenda, actually, we have just a quick introduction of the release. So for every community meeting, we create one release, and Stanley is gonna tell us a little bit about what are the latest updates around VDK. And then Paul is going to be talking about roadmap for machine learning projects and what is there regarding machine learning in progress and so on. So yeah, Stanley, I'm gonna pass the word to you.
Yeah, okay. Hi guys. My name is Stanislav. People call me Stanley. So basically I'm one of the contributors to the project. Okay, and today we'll present this that usually Antoni is doing, but now he's on PTO. Okay, so the major features that we included in this release, which is just a marker release. Our release actually happened during all the time. So basically during the day, we could have different tags, which mean we have a different release. So let's start from the beginning. In the last few iterations, there was a huge contribution from the internal VMware data pipelines team that is related to the data jobs configuration persistent feature, which basically means that a lot of stuff are all the configurations related to data jobs are actually now stored in a relational database, and basically this brings a lot of improvements all over the place, and we actually added a couple of stuff on top of that to make it, let's say, more production ready. The next thing, the walk, the VDK stack walk, and in general the walks improvements that we're doing. Again, we made a couple of iterations toward final release that more or less, I guess, in the next community meeting we will be able to say that we are done. Next is about the data sources POC, which is still a pre-alpha, I would say, or a POC level of implementation that provides different types of data sources, like let's say data sources APIs, and a way to configure it just with a configuration, so you don't need any code. For any details, you can double check the changes that we have added into this release. So this will continue to evolve. So this is one of our key focuses in the next months, I would say. The other thing is that we created Oracle plugin basically with two things currently, having managed connection and having the options to ingest to an Oracle database. This is still in a pre-alpha version, so basically it will change significantly, most probably adding template support and stuff like that. And at some point it will become a full-fledged VDK connectivity support. So this good for us. And finally, in this release, actually, we added our final alpha support for the Jupyter notebooks. So this was a big topic for the team for quite some time. And now we have a couple of guides for everyone that's interested and could follow up. Our next steps in this direction is actually to make it, we call it beta, but during the alpha release, we identified a couple of improvements that need to be done. So basically it will continue evolving, and hopefully it will be in much better shape soon for the users of VDK. Basically, that's it. Of course, as usual, guys, if you are interested, you can double check the entire changelog. And of course, you can double check who are the contributors. And yeah, I guess that's it. Agi, back to you. Any questions in the meantime?
Okay. If there are no questions, thank you, Stanley. So, Paul, your turn. Yeah, perfect. Okay, we can see the repository now.
Perfect.
Mm-hmm.
So at the moment, we're looking for how the VDK can help support machine learning workflows. And like, there's still a lot of ideas about where we're going to go. But today I'm going to focus on how the VDK ecosystem could be used for running machine learning training jobs. And so, first of all, I'll just describe the problem in running machine learning training jobs. So, like, a machine learning engineer writes their Python code to train their model. They follow it like a Hugging Face tutorial online or a PyTorch tutorial. Then they need to figure out where to run it. And like, users just don't know where or how to run their machine learning jobs. And this problem is particularly bad if they have to run distributed training jobs. So like, obviously an ideal solution would be that it's easy to run your ML jobs, just one or two clicks or one or two commands. You should be able to like use it, like normal, just standard Hugging Face and PyTorch tutorials should work just as they're written in the tutorials. And like, you don't need to learn a lot of new terminology or domain information to run your machine learning jobs with the product. It should handle distributed training. When you're running training, you should be able to have visibility into the training. How is it going? Is the model learning correctly? There should be good configuration out of the box. And I should be able to write code locally instead of being forced to develop it in like a Jupyter notebook online. I should be able to develop it how I want. And it should be auditable and reproducible. Okay, so that's the kind of the goals of if you were doing machine learning, of a machine learning platform. At the moment, what a lot of machine learning engineers or machine learning teams will do is they will just write their code, rent a GPU by a cloud provider, clone their code there, and run the training on that GPU. And then when the model is created, just save the model and then let go of that GPU. This is obviously definitely the easiest way, especially like even when you want to run, if you have a piece of ad hoc code that you want to run, it's always easier just to manually start it up. But the problem with this is like that it's very messy if there's many people coming in, leaving and joining the team. It can become very hard to keep track of what the steps are required to get the code running. It's also just very tedious. And there's no like auditability in 6 months. If the model from 6 months ago is the best model, and then you try and rerun that training to produce that model again, you might not be able, and it'll be very hard to determine, well, did they make some changes to the code or the environment variables that they never documented? So when a training runs, we want to capture that entire state, really. We don't want this kind of manual, provisioning a node and then provisioning a GPU and then running the GPU manually. Another approach that teams use is using a project like Ray. So Ray is like a distributed machine learning framework. It works with every library, PyTorch, TensorFlow, scikit-learn. It's extremely efficient. There's really good support and there's really good docs. But the drawbacks are that like Ray requires a Ray cluster to be set up on your behalf. The code needs to be written specifically for Ray. And it has its own domain terminology, which is quite complicated because the problem they're trying to address is quite complicated. So like Ray has quite a high barrier to entry. In my opinion, Ray is to machine learning what Spark is to data processing. So I assume more people are familiar with Spark. And like Spark is a really good framework. Like it has extremely good throughput. Docs are good, the examples are good, and I have a lot of experience in it. But practically speaking, when I go to do most data manipulation tasks myself, I never use Spark because it's just too complicated. Like I'm not going to set up Spark to run just a few queries, and I'm not going to write Spark specific code. I would rather just write Pandas code because then I can copy examples from online easier. So that's how I feel about Ray. Like it is amazing and it is good, but like the fact that you have to invest so heavily in it at the start to see any benefit. And so I think that turns a lot of people off. Same for Spark. I think a lot of people now, more and more people, especially as computers get more and more powerful, are just opting to use Pandas. They don't rely on the distributed functionality anymore. And lastly, there's a project like Kubeflow. Kubeflow is part of the generative AI VMware reference architecture. Okay, Kubeflow is a good approach. It's complicated to set up, definitely. And on first impression, we would say that it has a low barrier to entry because it doesn't require us to modify our codes. We can run whatever code we've written on the platform. So all our existing projects can be migrated straight across. And we don't need to learn domain-specific terminology and concepts to get up and running, again, because they just run your code for you. However, this actually isn't true because Kubernetes exposes so much of the Kubeflow exposes so much of the internals of Kubernetes. In fact, like in Kubeflow, the responsibility is on you to package your machine learning project into a Docker image and to write the appropriate Kubernetes YAML file and to deploy that to the Kubernetes cluster. Like this is a nightmare because a machine learning engineer very likely won't have much experience with Docker, very likely won't have much experience with Kubernetes. And even if they have the relevant experience, it's a bit messy to leave your Kubernetes cluster exposed like this, where anyone can deploy custom CRDs to the cluster. So I'd say that downside of this is just a huge amount of burden on the ML engineer. So this is where I think that the VDK is well suited. It's well suited to tackle this problem. The VDK is split into two parts. There's the SDK and there's the control plane. Well, the control plane is essentially just a product which you give it Python code and it runs the Python code on a cluster for you. And this is a very powerful concept. So we could ask, so machine learning engineers could write their machine learning models in Python, submit the code to the VDK control plane, and it will run the code for them. Okay, so furthermore, because like we can provide well-refined base Docker images for machine learning tasks. These will have like the appropriate GPU drivers installed so they can connect to the GPU drivers on their Kubernetes cluster. We can also, you know, give them the appropriate, and we can also set them up with sensible default environmental variable configuration to help them connect to reporting platforms. And let me explain what I mean here. So if you're an application engineer and you work on Spring, you write your Spring web service and you deploy it to Kubernetes. You don't really know what's happening, but you want those metrics in Prometheus. You just hope that they're there. You just assume that they're there. And so like the way an application engineer would want their metrics in Prometheus, an ML engineer wants their metrics in an ML reporting platform. The ML reporting platform we're going to work with today is mlflow. So I hope, so that's kind of the overall idea. So I'm going to give a quick little demo now and show what changes I've made to the code to support this. I hope this is interesting. This is very technical now, the next few minutes, but we'll move off this quick enough. So I'm quickly going to show what kind of changes we have to make to the code to support this. And then I'll do a little demo of running a machine learning job on VDK. So I think this will speak to the power of VDK, a little code I had to change. Oh, sorry, I don't want, ignore the warnings, but what I have to do first of all is create a base Docker image that I thought was appropriate for running machine learning jobs on. So what I did is I used a PyTorch base image. I installed mlflow. This would kind of be like installing a Prometheus driver or something like that. I installed other libraries that were important for reporting the metrics. I then create my model. So mnist dataset is a dataset of handwritten numbers, so 0 to 9. It's a very basic dataset. The goal of a model is to identify what number is in that image, 0 to 9. So here I've created a model which should be able to identify what number is in the image. So I created like normally, I just followed the tutorial online to create this, load my data set like normal, and create my trainer like normal. Normally then when you're following a tutorial, you would call trainer.fit. You have to make one small adjustment to run it on the VDK platform. You do run training and then pass in a lambda, which is your training.fit. That's the entire code. So you write all the code exactly as you're used to, and you do one extra change, which is when you, instead of calling fit directly, pass in the lambda. Now in the config, of course, I was saying earlier that we provide a good base image. So VDK actually has support for this out of the box, different Docker base images. And its primary focus till this point was supporting different Python versions. But like if we go to support ML projects, we will broaden the kind of conception of what can be handled with that. So it won't be just called Python version anymore. It will be broadened to something like profile. And profile could be a Python 3.7, 3.8, 3.9. It could be a PyTorch with GPU. It could be a TensorFlow with CPU. So here we configure the profile to use. Here I said I want to use the PyTorch development profile. Now, what happens under the hood? Well, we will actually, before running your training, we'll actually initialize connections to your ML reporting platform for you. And then we'll report all the training metrics. We'll report all the loss and the epoch and everything in real time to your reporting platform. Okay, so let me just give you an example now. Okay, so this is my code. I've written my model. This is my config file. I've specified my development environment. So now I just, like when you're deploying a job to VDK, I pass in a title, VDK. So you pass in a title and a description of the run, and then you deploy it to the VDK ecosystem. Okay, so that's deploying. So what happens there? Well, if we look on the cluster, oh, sorry, wrong cluster. If we look on the cluster now, we can see a builder running. So this is taking our PyTorch base image and it's putting our code into it essentially. I'm going to push that to Docker registry so that it can be run on the Kubernetes cluster later. Now, I'm just going to, so now once it has been built, you can then run it. So I'm going to run a version I built earlier, obviously. It'll have a different message here. But now here you can see the mnist-training running. And so when you start the training, what's good here is that we provide extensible config here. So we've automatically connected it to your mlflow instance. And so if we look at the logs, strange, is that successful? Here we can see the logs. Here we can see it ran for 3 epochs and it's all finished. Now, if we look at mlflow, so what's happened is we've created an experiment in mlflow, which has the name of the, you guys can still make, yeah, which has the name of the repo as the name of the data job as its experiment name. And then it uses the git commit messages to create the run name. So for us, the run name, if we waited for the build to happen, would be VDK monthly demo. And then within the VDK monthly demo, it would have used the description here to populate the description in mlflow. And here we keep track of all the metrics. So here we can see that the optimizer was whatever, and the epochs was 3, and the like all the different metrics we keep track of. And so as we run different experiments, we can compare different experiments now. So now in the future, we keep track of history of all experiments. So we can actually see, for example, that the training loss for the blue line this guy has the best training loss. So if we were deploying a model, we should deploy this guy. And what's cool is that, again, you just wrote, like, I don't want to complicate this demo. You just write normal machine learning code, deploy it to the Kubernetes, deploy it to the VDK ecosystem, and we run it for you and get your metrics where you want them. It's quite simple.
Paul, there's
yeah.
a question. Maybe you can check that.
Oh, sorry.
In the chat.
Yeah, just 1 second. So how is the, like, it's for creating models. So are you asking how do we move the model out of the Docker image once the training is completed? Sorry, Sabia, I don't fully understand the question. Yes, after training the model. Okay. So at the moment, responsibility is on you. You know, you can call model.save and pass in the S3 repository where you want it. But in the near future, like before we even release this, we will automatically register the model for you in mlflow. We will register small models and save them to cloud storage. And for very large models, we'll actually save them, because some of the models for LLMs can be like 100 gigabytes. We'll actually save them to a persistent volume on the Kubernetes cluster. But then mlflow is still able to discover that model after it's created. So the answer is, at the moment, if you were to use this today, the responsibility is on you to save the model, but within 3 or 4 weeks, we'll save the model for you. The keyword for mlflow experiment is provided. I'm sorry, I don't understand that again. Can you just elaborate a small bit on that? Like, tell me what screen to go back to, or? So which keywords? Maybe I can give you control for 1 second. Sorry, I still don't understand. Is it in this mlflow stuff?
Hello, am I audible?
Hello?
Hello.
Hello? Yeah, I can hear you, yeah.
Yeah, can you go back to the mlflow screen? In that, I could see the keyword as mnist-training for the experiment. So I'm asking, how is that linked like after training?
Yeah,
How is
that's a
the
good
name coming?
question. Yeah, of course. So what happens is, okay, let me actually just go to the code first. So in the code, when we're registering a run with mlflow, we pull 2 environment variables, which is the mlflow run name and the mlflow experiment description. If we look at the environment variables that have been passed to the running pod, you can see that the experiment name is mnist-training. So basically what we do is we attach the data job name to the pod, and then the pod reports it into the mlflow reporting platform.
Okay, and this is configurable, right? We can change it.
You could change it. Well, what I would encourage is that you name your data job to be your kind of experiment name. I think that's
Got it.
like,
Okay.
that seems intuitive to me. If you disagree, Yeah, like at the moment it's set up so that the project name is the experiment name in mlflow to make it kind of easier to track which is what, make audibility easier, just make it more intuitive.
Got it. Yes. Thank you.
No problem. Is there any other questions now? Okay. Okay, I'll just quickly go into one other thing, but I'm not going to keep everyone here for too long. So Kubeflow is a very powerful framework, but as I was saying, it requires the machine learning engineers to have a lot of Kubernetes experience. One particularly cool feature of Kubeflow is Katib. Okay, so what Katib is, it's a hyperparameter optimization tool. So it will help you find the best hyperparameters for your model and also the best neural architecture for your model. It works regardless of its PyTorch or TensorFlow, it works. It's very cool. And it has pretty good UIs as well. But if you follow the quick start guide, what they start with is Kubernetes YAML files and a predefined, pre-configured Docker image that they've built for you. They don't expect you to start from your code and move all the way to hyperparameter optimization. And they don't even really go through how they created that Docker image. So that leaves a lot of responsibility on the machine learning engineer. Following this tutorial is essentially useless because it only tells you how to optimize a Docker image. You don't know what's in it. So I see that the VDK could be extremely useful here. Again, you just write your machine learning code and we will run it for you. But if you wanted to do hyperparameter optimization, we were thinking we could support something like hyperparameter search space, and you pass in hyperparameters you want us to search. Defined as a pydantic class with like the default values and the limits and a description. And then when we're packaging the Docker image, we'll package it such that those are exposed as environment variables, allowing them to be configured by Katib. And then we'll deploy it to the Kubernetes ecosystem and do the hyperparameter search for you. And that obviously almost comes as that's almost free functionality for us because Kubeflow provides operators for doing that on your Kubernetes cluster without even installing the whole Kubeflow ecosystem. So that would be cool functionality that we could provide quite easily. I'm going to leave it there. I think that's enough. I don't want to go into. That's like a brief overview. I don't want everything else to be too specific. Yep.
Paul, there's another question.
Yeah, I will share the Docker file. So the Docker file I'm currently using is actually online. So here it is. So unfortunately, there's all these warnings, but it's just use the PyTorch base image. With
You're
the
not
GPU.
sharing the screen now.
Oh, sorry. Okay, so first of all, I'll put into the chat pull request. Sorry, where's that gone? So in that pull request, you can see the Docker image, and all it is it's PyTorch, Kubeflow, PyTorch Lightning, a Postgres driver, and just renaming something. So it's very basic image. But if you work in a company and if you use weights and biases instead of mlflow and you prefer with this that you always install these libraries as a prerequisite. Of course, you can do that. Of course, we encourage you to create your own Docker image. Okay. If no one has any questions, I think I'll leave it there. Okay, thanks, guys.
Thank you, Paul. Yeah, regarding this, I just wanted also to mention that at the moment we are working, or we are trying to find people who would like to use these whatever we're doing, like whatever is in kind of this proof of concept stage, and working with some possibly students or people who are doing some research, like academic research or any projects that you might have. Just reach out to us, or maybe to Paul, even just you can find him on LinkedIn, and then we can collaborate together to actually support these type of projects to start to get going and start using VDK. Stanley, you wanted also to say something?
Yeah, I just wanted to add that on our contribution page, so not contribution page, but on our README, the main README, there is also other ways to contact us. So basically, if you are interested, we have also a Slack channel and stuff like that. So whatever makes sense for you, please reach out and ask any questions or raise any discussion that you might have. We'll be more than happy to answer those.
Cool.
Yeah, to conclude, I just want to I think we haven't set like the date for the next meeting, but usually it's something like the end of each month, so it could be like end of January. But if you go to LinkedIn and you find the Versatile Data Kit, you can also share this link. Here on the bottom, you can see all the previous and like future events that we have, and each of them is one community meeting. So whenever we have one, it's here. And also all the recordings are shared on LinkedIn and also on the wiki page in the community and community meetings. Each meeting that we have, everything that we have discussed so far has a recording and is like structured in this page. So I'm gonna share it. This is LinkedIn, and this is the community meeting page. So yeah, if you like what you're doing, if you would like to support us, also don't forget to put a star on our repository. Please don't unstar it. So last time, I think when I said this, we lost 2 stars, because if it's already yellow, it means that you have already given us a star. And yeah, thank you everyone for joining. Thank you for being around, and see you next time.
Thank you. Bye, guys.
Yeah, bye-bye.
Thank you.
Thanks, guys.
Thank
Bye.
you.
Thanks. Goodbye.